China has built a bridge that turns a 2-hour mountain journey into a 2-minute drive. And then, in a wonderfully strange twist, it built an entire tourist complex to persuade them not to leave. There is a glass observation hall beneath the road, a cafe near the top of a tower, a racing track hidden inside the structure, and, for anyone who looks at a perfectly good bridge and thinks, I should jump off that, an extreme sports platform. It even releases the world's highest artificial waterfall. This is the Huajiang Canyon Bridge in Guizhou, southwestern China. Its deck hangs more than 625 meters above the river. In April 2026, Guinness World Records certified the figure at precisely 626.01 meters. That final centimeter is not especially useful to drivers. It is, however, very useful when you own the world record. But the height is only the first surprise. The bridge crosses a canyon where the wind can change from a breeze into a violent blast within minutes. Its main span is longer than 14 football pitches. Nearly 40,000 thin steel wires help hold it in the sky, and parts weighing more than 200 tons had to meet above the gorge with millimeter accuracy. The obvious question is not simply why anyone would build here. It is what had to be invented before building here became possible, and why China designed the world's most extreme shortcut to become a destination in its own right. Guizhou has spent centuries being shaped by one stubborn fact. Almost nowhere is flat. Mountains and hills cover 92.5% of the province. The landscape is cut by rivers, limestone formations, and deep karst valleys. An old description says there are not 3 level miles in Guizhou. Modern road builders might consider that less of a proverb and more of a complaint form. For villages facing each other across the Huajiang Canyon, being close on a map did not mean being close in real life. Reaching the opposite side meant following twisting mountain roads for as long as 2 hours. The canyon was not just scenery. It controlled where people could work, sell produce, study, or reach services. Guizhou's response has been extraordinary. By 2022, it had more than 30,000 bridges built or under construction. On its expressways, there were roughly 1.7 bridges for every kilometer of road. At that density, the road occasionally feels like the gap between bridges. The Huajiang crossing became the critical point on a new 150-kilometer expressway between Liuji and Anlong. Yet deciding to cross was easier than deciding where the road should go. Push the route lower into the mountains, and the bridge becomes smaller, but the tunnels grow longer. Raise the road, and the tunnels shrink, but the bridge begins to look unreasonable. Engineers compared both extremes and settled on a compromise that still sounds excessive. About 3.5 kilometers of tunnel feeding directly into a 2,890-meter bridge. And the tunnels were only one way through. Again and again along the expressway, entire ridges were opened from above. Excavators and controlled blasting removed rock until the mountain formed a gigantic V-shaped cutting, with the road running through the narrow floor. From the air, it looks as if somebody used a knife large enough to require planning permission. Cutting the mountain creates a road, but it also creates 2 fresh slopes that may send rock, soil, and rainwater straight back onto it. So the exposed flanks became engineering projects of their own. Different sections used protective mesh, anchors, concrete frames, and arched skeletons to hold the surface in place and control erosion. Soil and grass were added where vegetation could take root. On difficult coal-bearing slopes, project research describes protective cement soil layers beneath new planting. Those geometric ribs visible across the mountains are not decorative concrete. They are there to keep the newly cut landscape from reclaiming the highway. The route therefore attacks the terrain 3 ways: tunnel through a mountain, cut open a ridge, or jump across the void. The bridge is the spectacular part, but it only works because the road repeatedly reshapes everything leading to it. Construction began in January 2022. The main works would eventually cost about 2.2 billion yuan. Before the first cable could cross the gorge, however, the designers needed to answer a more basic question. What, exactly, do you attach a bridge of this size to? The Huajiang Canyon is carved through complex karst terrain. Limestone can look solid at the surface while hiding fractures, water channels, and cavities below. A suspension bridge cannot negotiate with doubtful rock. Its cables pull with enormous force, and that force must eventually be delivered into the mountain. The solution was a single main span of 1,420 meters, suspended between 2 towers and anchored into opposite sides of the canyon. It became the longest span mountain bridge of its kind in the world. The 2 towers are not identical. One rises 262 meters, the other 205. The terrain dictated different heights and different structural conditions on each side. Symmetry may look elegant on a postcard, but mountains are famously indifferent to postcards. Then came the cables. 2 main cables, each almost a meter thick, carry the weight of the deck, traffic, and wind back through the towers to the anchorages. Each cable contains 217 strands. Each strand contains 91 wires, only 5.7 millimeters thick. Add them together, and almost 40,000 wires are holding up the bridge. Laid end to end, their combined length would circle Earth more than twice, yet strength was only half the problem. A cable sealed high above a humid canyon must remain healthy for a design life of 100 years. Engineers cannot unzip it every weekend for a quick look. So 3 smart strands were embedded inside each main cable. Fiber optic sensors now monitor stress, temperature, humidity, and vibration in real time. The bridge does not merely carry traffic, it reports on how carrying traffic feels. If moisture rises, a connected dehumidification system can intervene. If loads change, the control center can see the response. The largest structural component has, in effect, been given a nervous system. That solved the forces inside the bridge. The air outside it was less cooperative. The Huajiang Canyon acts like a giant wind instrument, except its favorite note is evacuate the construction site. Gusts can reach force 14. Winds funnel through the U-shaped gorge, accelerate, change direction, and disappear almost as quickly as they arrive. During one construction episode in January 2025, a blast shattered windows in the project's temporary buildings while crews were still working above the canyon. At the highest point, the narrow construction catwalk hung about 780 meters above the river. Workers later admitted that their legs shook on their first crossing. This seems less like fear and more like a functioning relationship with gravity. Conventional weather forecasts were not precise enough for a gorge with its own microclimate. The team worked with researchers to install Doppler lidar units that fired lasers into the air and tracked moving particles. After a year of observations, they could read the canyon's wind patterns well enough to issue warnings up to 6 hours ahead. That knowledge shaped the bridge itself. Wind tunnel tests led to a streamlined steel truss and an unusual system of upper, lower, and central stabilizing plates. The shape reduced wind loading. The central plate sharply limited sideways vibration. And here the project's 2 personalities began to merge. The lower stabilizing structure was also designed to become an aerial racing track. A component created to keep the bridge calm in violent wind would later give visitors somewhere to run beneath the road. Only after the builders had learned when the air was safe could they attempt the most delicate part, moving an entire steel roadway through that air. There was no crane tall enough standing in the river below. There was barely a sensible place to put one. So the canyon itself became the crane. High-capacity cables were stretched between the completed towers to create an aerial lifting system. Instead of raising steel from the canyon floor, this 4th-generation smart cable crane carried each section out over the void. The bridge deck was divided into 93 steel truss segments weighing a combined 21,000 tons. Cameras, sensors, China's Beidou satellite navigation system, and an internet-connected control platform tracked every movement. Outside periods of dangerous wind, the system could operate around the clock and perform parts of the lift automatically. The job still sounds impossible when reduced to its final instruction. Pick up a section weighing as much as a small building, move it 600 meters above a river, and connect it to another piece with millimeter precision. Please do not scratch the paint. The segments followed a carefully planned lifting sequence so that the changing loads remained controlled. The intelligent system cut roughly an hour from the alignment of each segment. All 93 were positioned in just 73 days, a task officials said would traditionally have taken about 6 months. On January 17, 2025, the final section, about 215 tons, moved into the remaining gap. For most of the project, success had been measured in towers, cables, and thousands of tons. At the final connection, it came down to millimeters. The 2 sides met, but a completed bridge is not automatically a trusted bridge. Before ordinary cars could cross, engineers needed to reproduce the most unfriendly traffic conditions they could reasonably arrange. In August, heavy trucks began rolling onto marked positions. First 18, then 48. Eventually, 96 trucks stood on the deck with a combined load of roughly 3,360 tons. In other words, the bridge's first traffic jam was carefully organized by engineers. The trucks were parked in different patterns to test uneven loading, cable forces, deflection, and movement. Dynamic trials then examined how the structure responded to vehicles in motion. Hundreds of measurements streamed back, while inspection teams watched a bridge bend, as every large bridge must, and checked that it returned exactly as designed. It passed. On September 28, 2025, the Huajiang Canyon Bridge opened with the rest of the Liuzhi-Anlong Expressway. Travel between the two canyon sides fell from about 2 hours to roughly 2 minutes. The full expressway cut the trip between Liuzhi and Anlong from 3 hours to around 90 minutes. The new bridge stood nearly 60 meters above the previous height record, which was also in Guizhou. When one province repeatedly replaces its own world records, the award ceremony must become slightly awkward. Yet the official height used throughout construction, 625 meters, was not the last word. In April 2026, Guinness World Records announced a surveyed height of 626.01 meters. The bridge had passed its engineering test. Now, it faced an economic one. Records attract attention, and attention was part of the plan. The investment group's chief engineer later acknowledged that toll income from the bridge alone would not recover the investment even across a 30-year operating period. Its case depended on the wider road network, faster regional movement, and new activity around the canyon. That explains why the tourism features were not decorations added after construction. Their mounting points and structural allowances were included from the first drawings. Inside the truss, maintenance passages became viewing corridors. The glass hall sits beneath moving traffic. A 207-meter glass elevator climbs beside the South Tower in about a minute, carrying visitors toward a cafe almost 800 meters above the river. There are swings, aerial sports, a running track, and a bungee platform, because apparently looking down was not producing enough adrenaline. And then, engineers found a use for the water. The waterfall began with an unexpected discovery inside the mountain. While excavating a tunnel at the bridgehead, crews encountered a strong flow of natural karst groundwater. On many projects, that would be treated only as a drainage problem. Here, engineers built a reservoir with a capacity of 4,000 cubic meters and redirected the flow into it. The captured water supplies the bridge's service area and irrigates farmland and orchards on the Guanling side. Only the surplus feeds a line of nozzles mounted along the deck. Together, they create a water curtain about 300 meters wide. By changing the spray pressure, operators can adjust the visible wall to nearly 100 meters high before the water continues falling from the 625-meter deck. Chinese state media describes it as the world's highest artificial waterfall. After dark, the water becomes a projection screen. Lasers, lights, images, and sound turn the falling curtain into a show staged twice each day. A geological surprise inside a tunnel became a reservoir, an irrigation supply, and finally, a tourist attraction. Apparently, even the construction drainage needed a second career. So the bridge crosses a canyon, monitors its own nerves, predicts the wind, carries a road, contains a sports venue, serves coffee, and performs a light show. It is less a bridge than a very ambitious building that forgot to touch the ground. The strategy appears to be working. By January 28, 2026, only 4 months after opening, the attraction had received more than 1.3 million visitors, while over 200,000 vehicles had crossed. During the first major holiday period, tourism around the bridge generated more than 100 million yuan in reported revenue. Those numbers do not prove that a 2.2 billion yuan bridge has paid for itself. They reveal something more interesting. The canyon is no longer treated only as an obstacle. The same geography that isolated communities is being sold as the experience people travel to see. Nearby villages have opened accommodation, restaurants, and stalls. One local resident told Chinese media that the journey to the county town had fallen from 2 hours to 2 minutes. During the 2026 Spring Festival, his food stall beside the bridge earned 5,000 to 6,000 yuan in a day. The most important record may therefore be the one that cannot be photographed from a drone. Before the bridge, distance here was measured less in kilometers than in switchbacks, weather, and lost time. Now the gorge can be crossed during a short song. The structure did not remove the mountains. It changed what the mountains mean. That required a tunnel and bridge compromise, unequal towers, nearly 40,000 wires, laser wind tracking, 93 airborne steel sections, and 96 trucks deliberately creating gridlock in the sky. Then, after spending years making sure nobody would fall from it, the builders opened a place where tourists can pay to jump. Would you take the 2-minute drive and keep moving, or stop for coffee, step onto the glass, and discover exactly how much you trust Chinese engineering?